So, it's kind of hard to miss all the talk about artificial intelligence lately, isn't it?
It really is.
I mean, you've got King Charles mentioning its potential, the UN Secretary General calling it unprecedented, even the Pope's weighing in. It just feels like
Mm.
AI exploded onto the scene like overnight this past year.
Yeah, the acceleration in just, public awareness has been pretty remarkable.
Evidently.
And to help us all get a handle on it, we're going to dig into a really useful guide today. It's the World Travel and Tourism Council's Introduction to Artificial Intelligence Technology Guide for Travel and Tourism Leaders.
Exactly. And that's our goal here to sort of unpack this guide for you, our listener.
Mhm.
So whether you're, maybe a leader in the travel industry thinking about strategy or just someone trying to understand the basics, or maybe you're just curious about this tech that seems to be changing everything.
Right.
We want to give you a clear, hopefully engaging and digestible picture of what AI actually is, where it came from, and why it's suddenly so prominent, especially looking at it through the lens of travel and tourism.
And the WTTC report does a good job structuring this. It starts with a history, then defines AI, explains kind of the mechanics, the algorithms, data, computing power, which are crucial.
Okay.
Then it looks at the different types, including generative AI, which everyone's talking about, and finishes with some of the big global considerations.
Right.
So we'll use that structure basically to give you a focused way to get the essentials.
Think of this as your, I guess, shortcut to getting up to speed. We'll pull out the key stuff from the WTTC, share some maybe surprising facts, and hopefully make it interesting.
Sounds good.
So let's kick things off with the history. AI feels so new, but it actually has quite a backstory, doesn't it?
It really does. I mean, this current wave feels very 2023, but the foundations, they go way back to the post-World War II era. It really started taking shape as like a proper field of study at the 1956 Dartmouth Conference. That's actually where the term artificial intelligence was coined.
Okay. So that was the starting point for serious academic work.
Yeah, exactly. Exploring the whole idea of creating machines that could, think.
But it took a while for it to really grab like public attention, right?
Right.
I remember way back in '97 when IBM's Deep Blue beat Gary Kasparov at chess. That felt huge at the time.
Oh, absolutely. That was a landmark. It showed everyone very publicly that an AI algorithm with enough computing power behind it could beat a human world champion at something incredibly complex and strategic.
Yeah.
And then you fast forward a bit to 2011, IBM's Watson winning Jeopardy.
Right. Jeopardy.
That showed AI could handle vast amounts of information and, crucially, natural language. Understand the questions, find the answers.
Uh-huh.
Those were moments that definitely sparked curiosity, even if the tech itself was still a bit of a black box for most people.
For sure. And more recently, AI has been making waves in places you might not immediately think of, like Google DeepMind's AlphaFold predicting protein structures. That's huge for healthcare, right?
It's a fantastic example. It shows AI tackling these incredibly complex scientific problems. Predicting protein shapes, I mean, that could totally change how we develop new drugs and understand diseases.
Wow.
Really highlights AI's ability to handle stuff that's just, well, beyond human scale.
And it's not just science or games either. The art world's been buzzing too. Remember that AI-generated painting, Edmund de Bellamy, selling for a fortune back in 2018?
Oh, yeah?
That really kicked off a debate about creativity, didn't it? Like, who's the artist?
It absolutely did. And that conversation has only gotten louder. We've seen AI art getting more and more sophisticated, like that girl with glowing earrings exhibition in The Hague.
Right, replacing the Vermeer temporarily.
Exactly. And then the whole controversy with the Sony World Photography Award, where an AI image won, but the creator then refused the prize.
Yeah, I remember that.
It just throws into sharp focus how fast AI creative tools are advancing and how we're all still figuring out what it means. Makes you wonder about travel marketing visuals in the future, eh?
Totally. And music, too. The Grammys are now allowing AI-generated music. Paul McCartney used AI to isolate John Lennon's voice for that final Beatles song.
Now and then, yeah.
And Grimes is even letting people use her voice for AI songs and sharing royalties.
It shows artists are really engaging with this tech, finding new ways to create. And again, for travel, you could imagine, I don't know, personalized destination soundtracks or AI-composed music for videos. Lots of possibilities.
But it hasn't all been positive buzz. The Hollywood strikes last year, AI was a big part of that, right? Concerns about jobs, digital actors.
Definitely. Those concerns about jobs, about using digital likenesses, they echo across many industries. You think about customer service and travel. AI avatars are getting realistic. What does that mean for the human touch?
It's a big question.
Yeah, It is. And then there's the whole disinformation thing. Those fake pictures that went viral, the Pope in that white puffer jacket, or the fake arrest photos.
Right. They look so real. It was genuinely disturbing.
It
It
was.
just shows how good AI is getting at creating convincing fakes. For travel, that means needing to be really careful about fake reviews or misleading photos of hotels or destinations. Trust is key.
It's funny you mentioned trust because then you have someone like Lionel Messi apparently okaying deepfakes of himself for ads.
It shows different perspectives, doesn't it?
Mhm.
In some cases, with consent, maybe for commercial use, there's more acceptance. It's complex and evolving.
But the real game changer, the thing the WTTC report calls the tipping point for public awareness, that was ChatGPT landing in November 2022.
Absolutely. ChatGPT just made AI feel real and accessible to millions, practically overnight.
Uh-huh.
Its ability to generate text that sounded, well, human on almost any topic.
Hmm.
It just captured everyone's imagination. Getting over 100 million users in just a couple of months is staggering.
It really was. And then suddenly you had Google Bard, Microsoft Copilot. These AI chatbots were everywhere.
Exactly. It democratized AI
Yeah.
in a way. It wasn't just for researchers with supercomputers anymore. It was suddenly on everyone's phone or laptop.
Yeah.
And that has huge implications for how travel businesses can interact with customers, manage bookings, everything.
Okay, so that whirlwind history gets us to now. But let's pin down what exactly is AI. The WTTC report notes there isn't one single definition everyone agrees on.
That's true. It's a broad field. But the Oxford English Dictionary gives a pretty good working definition. It says AI is the capacity of computers or other machines to exhibit intelligent behavior.
Okay, intelligent behavior.
Yeah.
What does that actually mean in practice?
Well, it means systems that can seem to think, learn, act like humans. Sometimes even better than humans at specific tasks.
Right.
So analyzing huge amounts of data, solving problems, making decisions, even creative stuff. All things that could be applied in travel, think personalized recommendations, optimizing flight routes, that kind of thing.
And the report boils down the recent explosion to three key things: better algorithms, tons of data, and way more computing power.
Exactly. Those are the three pillars driving what we're seeing now.
So let's dig into those. Starting with algorithms, the brains of AI, as the report puts it. How are they different from regular computer programs?
Okay, so traditional programming is very much rule-based. A human programmer figures out all the steps and writes explicit instructions, often using that if-then-else logic.
Like, if seats available then allow booking, LC show sold out.
Precisely. The intelligence comes directly from the programmer's rules. But imagine trying to write rules for every possible travel query a customer might have. It gets incredibly complex, fast, and probably wouldn't cover everything.
Right, you'd miss nuances.
Exactly.
Hmm.
AI takes a different approach. Instead of being programmed with explicit rules for how to solve a problem, AI systems learn how to solve it by looking at lots and lots of data.
Ah, okay. The report used an analogy of a driver learning routes based on experience, not just program directions.
That's a great analogy. An AI system learns the best path or the best recommendation by analyzing past examples, not by following a fixed map.
So an AI travel planner learns from millions of past trips what people like, rather than needing a human to write a rule for every preference.
You got it. That ability to learn from data is what makes AI so powerful for things like personalization and travel.
That's really interesting, but it also makes me wonder, how do they reach their conclusions? The report mentions explainable AI. Why is that important for, say, a travel company?
That's a crucial point. We can see what an AI suggests, like book this hotel, but understanding why it suggested that specific hotel isn't always straightforward.
Because the AI figures out the steps itself.
Exactly. It finds patterns and connections in the data that might not be obvious. Sometimes AI systems are called black boxes because even the creators might not fully grasp the reasoning behind every single output. So explainable AI is about trying to make those decision processes more transparent. For travel, you need that trust. Why is this flight being flagged? Why am I getting this specific tour recommendation? Explainability helps build that trust.
Got it. So how do these systems actually learn? The report mentions machine learning and deep learning. What's the difference?
Right. Machine learning, or ML, is the broader category. You train the AI on lots of data so it can spot patterns or make predictions. Think weather forecasting or identifying hotels and images.
Okay.
Deep learning, DL, is a more advanced subset of ML. It uses things called artificial neural networks, kind of inspired by the human brain's structure for really complex tasks.
Like what?
like understanding your spoken request for flight information, generating realistic images of destinations, or analyzing thousands of customer reviews to understand sentiment.
And we should probably give a nod to the pioneers here, the godfathers of AI, LeCun, Hinton, Bengio.
Absolutely. Their work on deep learning was fundamental. They won the Turing Award for it, which is like the Nobel Prize for computing.
And the Turing Award itself is named after Alan Turing, right? The code breaker.
The very same. Brilliant mathematician, code breaker. And he proposed the Turing test way back in 1950, that idea of testing if a machine's intelligence is indistinguishable from a human's. Still a benchmark concept today.
So whether it's ML or DL, how are these algorithms actually trained? What are the methods?
The WTTC guide mentions three main ways. First, supervised learning. That's where you train the AI on data that's already been labeled with the right answer.
Like showing it pictures labeled beach or mountain.
Exactly, or feeding it customer reviews already marked as positive or negative. The AI learns the patterns associated with those labels.
Okay, supervised. What else?
Then there's unsupervised learning. Here the data isn't labeled. The AI has to find patterns and structures on its own.
How would that work in travel?
Maybe finding hidden groups or segments within your customer booking data that you hadn't identified before. Discovering patterns you didn't know existed.
Interesting. And the third one?
Reinforcement learning. This is learning through trial and error, essentially. The AI gets rewards for good actions and punishments for bad ones.
Like training a dog.
Sort of. Think of an AI learning the best dynamic pricing strategy for airline tickets. It tries different prices, sees the results, bookings, revenue, and learns over time what works best to maximize the reward.
Okay, supervised, unsupervised, reinforcement. Got it. So algorithms are the brains, but the report really stresses that data is the fuel that drives AI. Why is data so critical, especially for travel?
Well, simply put, algorithms need data to learn anything useful. The more good, relevant data you feed them, the better they get.
Right.
Better at spotting travel trends, predicting demand for flights or hotels, personalizing offers, all the stuff that makes AI valuable for the industry. That phrase, data is the new oil, really isn't an exaggeration.
And the amount of data being created is just insane, isn't it? The report mentions a stat from 2013 saying 90% of all data had been created in just the 2 years before that.
And it's only accelerated since then, exponentially. The European Parliament estimated we might hit 175 zettabytes a year by 2025.
Zettabytes? How big is that?
Okay, think of a high-end laptop with maybe a 1 terabyte drive. A zettabyte is a billion times bigger than that.
Wow. Okay, that's a lot.
It is. It's growing so fast they've even had to invent new measurement units, ronabyte and quettabyte.
Incredible. So what's generating all this data and how is it relevant to travel?
The WTTC points to three main things. One, just more smartphones and internet devices everywhere. Cisco thinks there are nearly 30 billion connected devices now, many used by travelers, obviously. Two, social media, people sharing photos, reviews, check-ins, huge amounts of travel-related data generated every minute.
Right. Billions of posts.
And three, new tech-like sensors, the Internet of Things, IoT. Think smart luggage, connected hotel rooms, sensors monitoring airport queues, all generating data. Cisco puts IoT devices at nearly 15 billion.
And all this data needs storing and processing, hence the rise of cloud computing in these giant data centers.
Exactly. And this massive, messy pool of data is what we call big data, often described by the 4 Vs. Volume, how much; velocity, how fast it comes in; variety of different types, texts, images, sensor data; and veracity, how trustworthy it is.
Okay, the 4 Vs. And how does this big data specifically help AI in travel?
In loads of ways. It's the training fuel for models used in, say, self-driving airport vehicles or personalized booking sites. It helps AI pull out useful info from photos or reviews. It improves chatbot performance. It powers predictive analytics for forecasting demand. It allows for that hyper-personalization of offers. It's essential for natural language processing so chatbots understand you. And it supports real-time decisions like dynamic pricing or fraud detection.
The report also mentions data warehouses and data lakes. What's the difference for a travel company?
Think of a data warehouse as like a very neat, organized library for structured data booking records, flight schedules, customer loyalty points, easy to query for specific facts. A data lake is more like, well, a lake. It holds everything: structured and unstructured data, social media posts, images, email, sensor readings. Less organized initially, but flexible for exploring different kinds of data.
So you might not know exactly how you'll use the data when it goes into the lake.
Right. And now there's also the data lakehouse concept, trying to combine the best of both. AI can work with both analyze structured data in a warehouse for pricing strategies or sift through unstructured data in a lake to gauge traveler sentiment from social media.
Got it. So we have the algorithms, the data fuel. Now the third piece, computing power, the machinery. The WTTC report says training these AI systems takes serious grunt.
Oh, absolutely. Think about training a chatbot on, say, hundreds of billions of words so it can understand and respond to complex travel questions. Trying to do that on your laptop, forget it.
Right.
It requires specialized, powerful hardware. Imagine an AI needing to effectively read and process the entire internet. A human couldn't do that in lifetimes. Supercomputers can crunch through it much, much faster because of their processing power.
And this power increase goes back to Moore's law, that observation about chips getting exponentially better.
Exactly. Moore's law drove decades of progress.
Yeah.
But for AI, especially deep learning, for things like analyzing travel images or understanding language, something else became critical: parallel processing.
Yeah.
Doing lots of calculations at the same time.
And that's where GPUs come in, graphics cards.
Precisely. Graphics processing units, or GPUs, NVIDIA really pioneered their use beyond just gaming and graphics. Their architecture is brilliant for the kind of math AI relies on.
Uh-huh.
Their huge market value, over $1 trillion, shows just how vital GPUs have become for the whole AI boom.
And the demand for these chips is so high, it's become a geopolitical issue, with the US, China, the EU all trying to boost their own chip capabilities.
Definitely. The Intel CEO said, there is no innovation without semiconductors. It's fundamental now.
Yeah.
And many big chip designers like NVIDIA or AMD are fabless. They design the chips but don't make them. Manufacturing is dominated by companies like TSMC in Taiwan and Samsung in South Korea.
Which creates supply chain risks like we saw during the pandemic.
Exactly. Chip shortages hit loads of industries. And the concentration in Taiwan, given geopolitical tensions, is a major concern. That's driving efforts like the U.S. CGPS and the EU CHIPS Act to diversify manufacturing.
And now the big tech companies, Amazon, Apple, Google, are designing their own AI chips too, like Google's TPU.
Right. Google's Tensor Processing Unit, or TPU, is built specifically for AI tasks. It excels at the matrix math that's core to machine learning.
Okay.
The report has a neat analogy. If a standard CPU is like printing one letter at a time and a GPU is like printing a line, a TPU is like a massive press printing whole pages at once, much faster for AI calculations. Google uses them for things like Translate, which is obviously huge for travel.
And for the really massive AI jobs like training ChatGPT, you need thousands of these chips linked together in supercomputers, costing millions.
That's right. Microsoft built one of the world's biggest supercomputers just to train OpenAI's models. It shows the scale and investment needed at the cutting edge.
Does that mean AI will worsen the digital divide if only huge companies or rich countries can afford that power?
That's a real concern.
Mhm.
But there are efforts to broaden access. The UK, for example, is investing in a powerful research supercomputer called Isambard AI. It's an exascale machine,
Exascale, meaning?
meaning it can perform an exaflop that's a quintillion, or a billion calculations per second. Making that kind of power available for research helps.
Wow. But for most travel businesses, they don't need their own supercomputer, right? Cloud computing helps here.
Hugely important point for the industry, yeah. Cloud platforms like AWS, Google Cloud, Microsoft Azure give companies access to immense computing power and pre-trained AI models on demand.
So they pay for what they use.
Exactly. They can leverage powerful AI without building the infrastructure themselves. They can even take existing AI models and fine-tune them with their own specific travel data, maybe customer interactions or destination info to make them more relevant. That takes way less resource than training from scratch.
Okay, so that covers the components: algorithms, data, and compute, often available via the cloud.
That's the triad.
All right, let's shift gears and talk about the types of artificial intelligence the WTTC report outlines. It mentions classifying them by learning method, capability, and functionality. We've kind of covered learning methods. What about capability?
Right. Capability refers to the AI's level of intelligence, basically. First, you have artificial narrow intelligence, or ANI.
Narrow intelligence.
Yeah, AI designed for one specific task or a narrow range of tasks. Think smart speakers in hotel rooms, chess computers, AI analyzing medical scans, or software identifying landmarks in photos for a travel app. This is pretty much all the AI we have today in practical use.
Okay, so ANI is what's real now. What else?
Then there's the theoretical stuff. Artificial general intelligence, AGI. That's the idea of an AI that could perform any intellectual task a human can. Learn, reason, adapt across different domains. We are not there yet.
Right, the stuff of science fiction currently.
Yeah. Pretty much. And beyond that is artificial superintelligence, ASI. Hypothetical AI that would vastly surpass human intelligence in every way. Also firmly sci-fi for now.
Okay, so ANI is the focus for practical travel applications today. What about classifying AI by its function, what it does?
The report highlights a few key types here. AI expert systems are one. These try to mimic the decision-making ability of a human expert in a specific field.
Like a travel agent AI.
Could be. Or maybe an AI diagnosing potential faults in aircraft engines based on sensor data. They use a knowledge base, facts, and rules from human experts and an inference engine to reason and give advice.
What are the benefits for travel?
Saves time, potentially costs. Can offer personalized service by drawing on a huge range of information, maybe combining travel agent knowledge with insights from travel blogs or reviews. Consistency, too.
Makes sense. What other functional types?
Predictive AI is another big one. Using past data to forecast future events.
Like predicting flight delays or hotel occupancy rates.
Exactly. Airlines use it to analyze weather, air traffic, past performance, etc., to predict the likelihood of delays. That lets them be proactive, maybe adjust schedules, alert passengers, manage crews more effectively.
And this predictive stuff often works with other analytics, right? Descriptive, diagnostic.
Yes, they complement each other.
Yeah.
Descriptive analytics tells you what happened. It could be bookings for destination X increased 20% last month. Diagnostic analytics helps figure out why is why, likely due to a new marketing campaign and competitor price increases.
Okay.
Predictive analytics forecasts what might happen. Based on trends, bookings are likely to rise another 15%. And prescriptive analytics suggest how to respond. Recommend increasing room allocation and adjusting prices. They work together.
Right. Which leads us nicely to the type of AI everyone seems to be talking about now, generative AI. The WTTC report credits ChatGPT's arrival in late 2022 with really bringing it into the spotlight.
It certainly did. ChatGPT's ability to create really fluent human-like text, generate code, answer complex questions. It just stunned a lot of people and drove massive interest.
So what is generative AI at its core?
It's a type of AI that creates new content. That could be text, images, video, audio, code, anything. It does this based on a user's instruction called a prompt and what it learned from its training data using a specific generative AI model.
So I could ask it to write a blog post about visiting Rome or create an image of a futuristic hotel lobby.
Exactly. And the powerful models behind systems like ChatGPT, which are trained on vast, diverse data sets to handle a wide range of tasks, are often called foundation models.
Foundation models.
They can write marketing copy, translate languages, generate software code, create presentations, summarize reports, lots of different outputs.
Where did this generative AI suddenly come from? Did it just appear with ChatGPT?
Not quite suddenly. A lot of the groundwork was laid earlier, but a really key moment was a 2017 research paper from Google called Attention is All You Need. It introduced an architecture called the transformer.
Ah, transformers, heard that term.
That transformer architecture turned out to be incredibly effective for processing sequential data, especially language. It's the basis for most of the powerful generative AI models we see today, including the ones behind ChatGPT.
And since then, research and investment have just exploded.
Massively. The number of scientific papers on generative AI, the venture capital funding, it's shot up. And you just have to look at news headlines or social media mentions in 2023 to see the phenomenal global interest it sparked.
And a specific type of these generative foundation models are the large language models, or LLMs. They're the ones powering the chatbots.
Correct. LLMs are specialized in understanding and generating human-like text. They use natural language processing, NLP, to interpret your prompt and then generate a relevant, coherent response.
So if I ask, who's the fastest man ever? It uses NLP to understand, accesses its knowledge, and generates something like Usain Bolt holds the world record.
Precisely. And good LLMs can do more. Remember the context of your conversation. Translate between languages, super useful for travel platforms. Summarize long texts, even format information into tables.
They're not perfect, right? The report mentions hallucinations. What's that about?
Ah, yes, hallucinations. That's a crucial limitation to understand. It's when an AI chatbot generates information that sounds plausible, confident, even factual, but is actually incorrect or completely made up.
Made up. Why?
Well, fundamentally, LLMs are pattern matching machines. They predict the next most likely word based on the patterns they learned from their training data. Sometimes that process leads them to generate text that fits the pattern but doesn't reflect reality. They don't know things in the human sense. They predict language.
So they can essentially confabulate convincing sounding nonsense.
That's a good way to put it. The WTTC report itself had an example where it asked an AI to create a table of WTTC reports, and the AI confidently listed reports with the wrong publication months and even missed some reports entirely.
Wow. Okay, so definitely need to double check important information generated by AI.
Absolutely. Especially for critical things like travel itineraries, visa requirements, or business decisions. Always verify AI output from trusted sources.
Good advice. So, despite the limitations, the generative AI market is booming with applications, open source models. Companies can even fine-tune them.
Yes, the ecosystem is growing incredibly fast. Fine-tuning means taking a general-purpose foundation model and training it further on your own specific data, say, a travel company's customer service chat logs, to make it better at your specific tasks.
There must be tons of applications emerging.
Huge numbers. That Sequoia Capital Market Map the report mentions gives you a sense of the diversity tools for writing, coding, image generation, design, data analysis across almost every industry.
And all this rapid growth has led to calls for regulation, like the UK's AI Safety Summit or the EU's AI Act.
Exactly. Governments and international bodies are grappling with how to manage the risks, disinformation, bias, job displacement, safety, while still fostering innovation. It's a global conversation now.
Yeah.
And groups like the OECD are stressing that we need international cooperation and policies that include everyone, including the travel and tourism sector, to navigate these challenges.
Which brings us to some of those broader challenges the WTTC report highlights, like the global digital divide and the AI skills gap. It notes that AI gets better with more data and power, but access isn't equal.
That's a really critical point. The International Telecommunication Union, the ITU, estimated that in 2022, about 34% of the world, 2.6 billion people, had never used the internet.
Never. Wow.
Yeah. So a third of the world currently lacks the basic connectivity needed to even access AI tools, let alone benefit from them. The ITU calls universal and meaningful digital connectivity a top global priority. The AI revolution has to be inclusive.
And cost is a big barrier, especially in poorer countries.
Huge barrier. In low-income economies, the cost of just basic mobile broadband can eat up a significant chunk of the average person's income. In the least developed countries, or LDCs, nearly two-thirds of the population remain offline.
That's stark. Are there efforts to address this?
There are. The report mentions the AI for Development initiative, launched by the UK and Canada at the UN last year. It aims to help boost AI skills and provide computing resources in developing nations, starting with Africa.
That sounds promising.
It's vital. You know that famous quote from William Gibson, "The future is already here, it's just not evenly distributed." That really nails the digital divide situation with AI today.
Yeah, that fits perfectly. And the ITU Secretary General also warned that just having a connection isn't enough. The skills gap is another huge barrier.
Absolutely. And this isn't just a problem for developing countries. Even in developed economies, there's a big gap between the demand for AI skills and the number of workers who actually have them.
Really? Even with AI being everywhere.
Yeah, surveys show surprisingly few workers have received formal AI training, even though AI-related jobs are booming and training is something employees really want.
Huh.
There's also a gap within companies. Senior staff might get training, but lower-level employees who might be more worried about AI taking their jobs often don't get the same opportunities.
So reskilling and upskilling are crucial.
Essential. Skillsoft called it out, and IBM estimated something like 40% of the global workforce might need reskilling in the next few years because of AI.
40%. That's massive. Are there resources available for people to learn?
Yes, thankfully. Major tech companies, Microsoft, Google, IBM, offer a lot of free introductory AI training online, often partnering with platforms like LinkedIn Learning, Coursera, or edX.
So people can start learning the basics for free.
They can. IBM, for example, committed to training 2 million people in AI by the end of 2026, focusing on underserved communities. And just look at YouTube, over 1.7 billion views of AI-related videos in 2023 alone. People are hungry to learn.
And presumably there are paid courses and consultants for deeper dives.
Of course. Plus, simple things companies can do internally, peer training, just raising awareness, maybe co-mentoring between different generations.
It sounds like AI education needs to be a lifelong thing, starting early and accessible to everyone, especially in those LDCs if we want to close that divide.
Absolutely. It has to be a priority, from government-led digital literacy programs right through to workplace training, to make sure AI benefits everyone, not just a select few.
Well, this has been a really, really insightful deep dive into the WTTC's guide. It certainly clarifies a lot about AI.
Glad it was helpful.
It definitely makes you think about how fast everything is moving, and it even makes you question if you could tell the difference between something written by a human versus an AI now. The report actually ends with a quiz where all the text and images were AI generated.
Yeah, it's getting harder to tell, isn't it? A good reminder of how far the tech has come.
For sure.
So we've covered quite a bit, the history stretching back decades, how AI works with algorithms, data, and compute power, the different types like narrow AI and the big one, generative AI, and these crucial global issues of access and skills.
Definitely. So, wrapping this up and thinking about everything we've discussed, given this incredibly rapid evolution and the sheer potential of AI, what do you think are maybe some of the most unexpected ways it might reshape how you, our listener, understand and experience the world in the next few years? Something beyond the obvious, building on what we've explored today. It really pushes you to think about the ethics, the possibilities, and just the need to keep learning, doesn't it?